So I'm going to make homework 4 due the same time that your test is due, which is on Monday. Fourth. First part of today's notes is to help you do the last couple of problems on homework 4. And you have your exam to work on. These are the same due date on Monday night at 11:59 p.m. Okay, so for my class, especially since it's an online test, I will still give you credit if all you put is an answer, but unfortunately, if it's the wrong answer, I'll take away points. If you show your work and I can see where the mistake happened, I may be able to add a few more points back. So you don't have to show your work, but it would probably help you get a better score, possibly, if you show work. And my best advice is to attempt every problem. Don't leave anything blank. Blank questions won't get any points. You can submit a PDF, like pictures for each question, or just if you want to send the whole test scanned, I'll grade that. Or you can type in your answers. There's unlimited attempts, there's no time limit, and I want you to succeed, but I also don't want you to get outside help. I mean, I understand working with a classmate, but still make sure that your answers are checked by you and your sentences or anything like that, your solutions are written in your own words. That's, I think, all I have to say about the test. Okay. So I have picked another set of problems from the book. I'm going to post these to Canvas and I'll post the answer key, but we're going to walk through each one together. Yes, I need to unlock the homework. I plan to do that after class, or at least by the end of the day. So we'll get that extension soon. So this is section 4.4. And all of the questions are from this section. The first question is number 7. see where this is. Ugh. Yeah, and if anyone's, I've also seen a message for an extension, and I need to check my emails. I'll get to those today. I'll make sure everyone has time to do all of their assignments. And even if you need extra time after that, we still have like the whole semester. So I'll make sure we can all finish everything that needs to be done. Okay, cool. I think I did this right. So we should all see a paint picture for 4.4. Okay, we're on number 7. We have one number is 5 more than 4 times another number. Their sum is 35, and you want to find the two numbers. Find these numbers. Okay, I want to give these numbers a name. So we're going to let X and Y represent the two numbers. Okay, so let's go over here. Or we're going to start one of the lines for our system. Let's call this one number. One number, we'll call it Y, is, so that's an equal sign. 5 more than 4 times another. So let's do the 5 times that other number. 4 times the X value. And then add 5 more. Then there's this other piece. Their sum is 35. So remember that is means it's going to be equal to. So from this part, you have X plus Y equal to 35. So what our goal is to solve a system. The system is the 2 lines working together. And you can use substitution or elimination. I mean, you could graph as well, but it's not very accurate. So I think substitution would be nice and easy. You can take this y equals that value, substitute it right there for that y. Okay, so we're taking the top line, substitute it into the other line, the bottom line. We're going to have x plus 4x plus 5 equal to 35. Y is 4x plus 5. We're going to put these like terms together. And I also want to subtract 5 in the same step. So taking away 5 from both sides. 5's going here. There's a 5x right there. And this is equal to 30. Divide each side by 5. And I've got x equal to 6. Okay, then go find the y value using either of those lines from the system. I like this one the most. So we're going to put in 6 right there for x. So we're subtracting 6 from each side. Got y equal to 29. If it were me, I would write my answer as a point. So we're going to put this pair together as 6, 29. Not quite sure. I don't really remember how the homework has your answer, but I'm just used to solving a system and either having the answer be a point, no solution, or infinitely many solutions. So this is kind of my style. The next one is number 13. We'll read it together. Oh, wrong one. Okay. Stop. And there we go. Ron has 14 coins with a total value of $2.30. The coins are nickels and quarters. How many of each coin does he have? Oh, it's number 13. and a total value of $2.30. And it's just nickels and quarters. And I need to find how many of each coin. Okay, we're gonna need to represent our quarters and nickels. So that first step is always to give your unknown value a name, or some teachers call that defining your variables. So part 1, let X equal number of nickels. Okay, Y will be the number of quarters. And then we will be able to write 2 equations. So the first one goes along with this part where you know that there are 14 coins. So whatever number of nickels added to whatever number of quarters is that total of 14 possible coins. And the value of whatever number of quarters or nickels you have is $2.30. So this equation looks like go down here to number of nickels. Let's use 0.05 and multiply that value for a nickel multiplied with the number of nickels you have. And then add it to the value for a quarter, 0.25, multiplied by your number of quarters, y. So we have a system of equations. Let's put these 2 lines together over here. This line is the 0.05x, 0.05x, add 0.25y equal to 230 or 2.3. And the other line is x plus y equal to 14. we could use substitution or elimination. But first, what I'm going to do is just rewrite my system. So I don't like any of these decimals. And we talked about clearing decimals with a multiple of 10. So before trying to solve this, I'm going to rewrite it and multiply both sides of the top line by 100. So you kind of want to move that decimal space 2 places over to the right. This side times 100. Same on this side. Now we have 5x plus 25y. And is equal to, it would be 230. And then we're just going to copy the bottom line. What I'm going to go with this time is elimination. And I want to eliminate the x variable by multiplying both sides of this bottom equation by -5. And then we're going to add the lines together. So I don't really need the bracket. Actually, I haven't needed the bracket this whole time. It just looks more like a system with this connection on the side. But this time I just want to have the lines stacked, and then we're going to add them together on the side. So the first line, just copy. And here is a -5x and a -5y equal to, let's see, 70, -70. So we've eliminated x. There's a 0x plus 20y. And is equal to, let's see, 160. And then divide each side by 20. So I've got y equals 8. I'm going to go back to the original line that was on the bottom of the system and find x. So the line was x plus y equals 14. And you know what y equals. So you've got an x plus 8 equals 2, 14. And x would be 6. And if it were me, I would put them together. So my answer would be 6, 8. Back to like, if you were writing it as a sentence, see, if x was the number of nickels, then you've got 6 nickels and 8 quarters. Okay, we are on number, I think it's 23. Number 23. And this one's very much like your homework. The numbers are just different. A farmer has 96 feet of fence to make a corral. He arranges it into a rectangle that is twice as long as its width. What are the dimensions? So we're going to use the formula for the perimeter of a rectangle. And we'll solve for, we'll use that sketch as well to solve for that value x, the length and the width. Twice as long as there's width. Yep. Okay. Solve for length and width. So this is where I'm going to put my fence. It should be a square shape. So I think you get it. Okay. There's one side labeled x, and the other side is twice as long. It's called 2x. 2 times x. See, x is going to be, we're going to let x be called the width, and 2x is going to be the length, or we can call, let me see. The picture kind of led me to this, but I think we should back up and make just a general sketch. Farmer has this much fence. Yeah, let's take this away. The book gave that picture, but we don't need to use it. So we're going to call this width. And we're going to call this, that's my go-to, but I also have, I'm going to be posting solutions for you, and I want you to be able to like check your notes with those solutions. So we are going to do matching variables. X is width. and then use y for length. All right. I just want to read the problem out. So he arranges the corral so that the rectangle is twice as long as it is wide. So, oh, I didn't put that down. X equals width. Y equals length. Whatever the width is, the length is twice as long. There we go. He has 96 feet of fence. So we can wrap 96 feet of fencing around this rectangle, which means we're going to add x with x, add this y plus y, and it's equal to 96. I'm just trying to get us all pieced together, and it's a little messy. So we had part of the problem where so the width is equal to 2 times the length. That's that part right there. Okay, also, he has 96 feet of fence. Okay, so we're going to take 96, and it's equal to the sum of all the sides of the rectangle, which is 2x plus 2y. So let's plug in y. 96 equals 2x plus 2 times 2x. I've got 96 equal to 2x plus 4x. Which means, oh no, I've already started solving the problem. Yikes. Okay. Let's back up. So I went and I just like jumped straight into doing this. But before we do, let's back. Let's write our system. Okay. The system is this line right here. 96 equal to 2x plus 2y. Okay. The other line that we created, or the other equation we had, was that y is equal to 2x. And then that scratch work I was already doing was solving by substitution. You could also use elimination, but it just looks really like straightforward to substitute that y value right there, this bottom line, into the top line. Okay, so I think we've got it all pieced together. All right, substitute. Get 96 equal to 2x plus 2 times y. And that's all you need. Okay, keep on going to solve for x. $96 is equal to 6x. Divide both sides. By 6. And then let's simplify x. Well, let's see. 96 divided by 6. I have the solution, I just want to check. Or if you want to check, that's also helpful. Yep, okay, it's 16. And then use either of your lines to solve for your y value. That bottom line would be really easy. So y is 2 times 16. $32. The width is 16 and the length is 32. Okay. There's 2 more practice problems. Let's do this. Thanks again for being patient today. I just wanted to pick random questions to go over. All right. We're on number 28. So it's about shares. It's not that bad. It just kind of sounds boring. All right. Kelly sells 62 shares of stock that she owns for a total of $433. If the stock was in 2 different companies, one sells at $6.50 a share, the other sells at $7.25 per share, how many of each did she sell? So we're going to set up a system of 2 equations. All right, let's kind of get all the info first and then define some variables and see what happens after that. She sells 62 shares of stock. a total of $433. One stock sells at $6.50. The other one sells for $7.25. Okay, so what we need to do is have our variables X and Y. One of them is for the stock that sells at that price, and the other one's for the stock that sells at the higher price. This one's going to be for the shares that sell at $6.50. Why is the number of shares that are selling for $7.25? So the first equation comes from knowing that there are 62 shares. So whatever number of this shares added to that number of the other shares is equal to 62. She sells them for that much total. So we're going to take 433. It's whatever number of shares times the value for that share added to whatever number of the other shares times its value gives you that total value. So we're taking 6.5x. Adding it to 7.25y. And then we're going to just write our system to be nice and clear what we want to solve and pick a way to solve. Okay, this line and this line are working together. X plus y is equal to 62. I'm just going to flip this around. So 6.5x plus 7.25y is equal to 433. Cool. And then the book or the solution just goes straight into using elimination, which is fine. I mean, another idea is to get rid of all the decimals, but let's just go ahead and eliminate x by multiplying both sides of this equation by negative 6.5. So we have a new version of the top line. It's negative 6.5x minus 6.5y. We'll figure out this number soon. That would be negative 403. Then copy the bottom line underneath. Add the two lines together. And we're able to eliminate x. For y, it's going to be 0.75y. Equal to 27. Or no, equal to 30. Divide each side by 0.75. And I got 40 for y. Let's use the original top line to get x. So what was there was x plus y equals 62. So subtract 40 from the side. I got x equal to 22. So it's 22 shares of the stock that costs $6.50 and 40 shares of the stock that costs $7.25. Okay, last one for chapter 4 problems. And then if we have extra time, I just want to do, I have the review from every chapter available. So we're going to pick random questions that are similar to test questions. Last one is about ticket sales. .4, number 30. So pre-event tickets for a local theater cost $30 and $40 for at-the-door tickets. So $40 for, I guess, general tickets, and at-the-door tickets cost more. Organizers sell a total of 200 tickets and have a revenue of $6,650. How many pre-event tickets and at-the-door tickets are sold? So we're going to set up two equations and solve a system. Stuff on the board. Okay, so tickets cost $30. At-the-door tickets are $40. They sell 200 tickets total. From that, they've got 6,650 in revenue. And find the number of each of the tickets sold. So we're going to have X be the number of tickets, the number of pre-event tickets sold. And then Y is going to be our at-the-door, number of at-the-door tickets sold. After we get through this one, we get to do review problems. It's much easier. Okay, so we're setting up variables, X and Y. Let X equal and Y equal. So X is our number of pre-event tickets sold. Y is the number of at-the-door tickets. Using these variables to set up two equations. One is the number of tickets sold. They sell 200 tickets. So whatever number of X tickets plus whatever number of Y tickets is equal to 200. Oh, I'm going to put that on the other side. And that's going to be a total of 6,650. The value for this ticket was $30, so it's 30x. This value is $40, so we're going to take 40, multiply with y, add the two together, and it equals that total, 6,650. Cool. So we're going to use elimination. I mean, we could use elimination or substitution, but we'll multiply both sides of this equation by -30, and that will eliminate that x variable. This side and this side by -30. Okay, so this is over here. And it's -30x minus 30y. Equal to -6,000. Pretty sure. Yep. -6,000. Copy down the other line. Just right straight across. Okay, we add the lines together. And that way we can eliminate x, 0x plus 10y equal to 650. And divide each side by 10. Y is equal to 65. And then we're going to use the top line to find x. I know what y equals. That's 65. Solve for x. And it's going to be 135. So back to what our variables were. We know that there were 135 pre-event tickets sold and 65 at the door tickets were sold. Okay, so that's the end of all the problems that will help you with your homework. And we've got about 10 minutes left. So we're going to start with some review for the test. And again, I have all the problems that we've done today on a PDF, the one that we were looking at, and their solutions as well. So those will be on Canvas. So review for exam 1, or review number 1. Do the first example, says simplify. Let's do 5, and let me see, pick the book. Let's just do like 5 times 9 minus 2x. Let's do 9x minus 6. So we're just taking this whole expression and writing it as simplified as possible, as easy to read as it can be. Okay, start inside of the parentheses. Like this one here has 2 like terms that need to be added together. Then x and x is 10x. Okay, let's distribute. First, we're distributing 5 to both terms. So 9 times 5 is 45. 5 multiplied with -2, so we're subtracting 10x. Distribute the negative sign. It's a minus 10x plus 6. Okay, add all like terms. So this 45 plus 6 is 51. And negative 10x and negative 10x is negative 20x. Okay, next one, we want to solve for x. Oh, okay, we want to do something like this with like 4x plus 3 equal to x let's plus 7 over 7. So I just want to point out that when The symbol is not multiplication. You cannot cancel the sevens. So this addition sign means like, do not simplify 7 over 7. What we will do is get rid of the fractions by multiplying both sides by 7. And let's see what happens there. Eliminate fractions. Multiply both sides by 7. Got 28x plus 21 equal to, so it's this 7 here canceling with that 7 down there, because we do have multiplication now. And what's left is the x plus 7. What I would do is subtract x from each side. And subtract 21 from both sides. Pretty sure, let's see. It's going to be negative 14. Just going to double check. Oh, okay, got the negative 14. Divide both sides by 27. So this is a weird fraction, but still should be correct. I get x equal to negative 14 over 27. You can leave your answers as fractions, or if it's a decimal, either way would work. Okay, the other one's solve for x with lots of fractions, but we know how to clear fractions. However, if you have any trouble with the test, just let me know. I'm always here to help. Okay, I'm going to mention how to find intercepts. So remember that to get x-intercepts, put y equal to 0. Y-intercepts, you have x equal to 0. I'll give you credit if you just solve for this x value and solve for the y value, but I also like the answer to look like a point, so I kind of prefer that you try to write this as a point. The first one's x comma 0, and the other point is where you have 0 comma y. Okay, we need to sum it up. So I'm just kind of peeking at the test to see what else you need to know. Find the equation of a line, use y equals mx plus b. Solve for m and b. What else? Equation of a line, solve a system. So we've been solving systems for the first part of class. And I just want to mention that I was not able to find a big curly bracket, but the systems are just two pairs of lines, one on top of the other. So last note is to solve your systems using substitution or elimination. last thing before we go is I do have office hour tomorrow, and if you want help on your test, I'm totally cool with that. So if you want to visit, I'm going to be around Friday from 1 to 2:30. I can help with any questions that you have, even test questions, quiz questions, homework help. Anything's fine. Okay, that's the end for today. Good luck on your test. Have a good weekend. And let me know if you have questions. Okay. Yikes.